So the final part of this blog post on 0.9, smarter transaction fees. Again, quoting from the blog post. Today, transaction fees are hard-coded into the Bitcoin QT/Bitcoin D wallet software, and the rules surrounding those fees are a collection of heuristics that evolved over the last 4 years. In short, the current fee handling code is a complicated mess that will stop working as soon as transaction volume doubles a couple of more times. In theory, it should be simple. Transaction fees should be set by a give or take between the people creating transactions, who want to pay as little as possible, and the people validating and storing the transactions, miners who would like to be rewarded with higher fees. And the code that miners are using today to select transactions is simple. They fill their blocks with the highest fee per kilobyte transaction and highest priority transactions if they choose to set aside some space in their blocks for free transactions.
From the early days of Bitcoin, I think the vision was always to make the transaction fees a market, an efficient market where the price of the transaction fee is set through equilibrium between supply and demand. Supply being the miners and demand being the end users of transactions. Effectively, you would have equilibrium at the best price possible on the network at any time, and you can make choices. You pay more, you go faster, you pay less, you get a slower transaction time. That was the vision. Unfortunately, it hasn't yet materialized, but this is a really good step in that direction. Here's the problem with the market dynamic right now. Even though miners are setting a price implicitly by choosing which transactions they put into a block, there's no simple way for that price to be communicated back to the market. So the problem here is price signaling. It's having a way to communicate that market price back to the client so the client can make intelligent heuristic decisions about what to pay for the next transaction in order to achieve a specific time goal. I have a transaction of 10K. How much do I need to pay today to get that transaction verified in 3 blocks by miners? That's the kind of question a client is asking.
That makes sense, but can we just go back for a second? I'm wondering how a miner, quote, decides which transactions to include. Like, how does that work?
Well, at the moment, they use the greedy algorithm, which is they look at all the transactions that are available, they sort them by the number of fees, and they take the ones that have the highest fees per kilobyte. You normalize it on the size of transactions, and then you put those first until you've got a block that's full or full enough to what you want to achieve, and then you post that block. So at the moment, it's basically highest price transaction first, or highest fee per kilobyte transactions go in first.
So that's an automated process. And where does that process happen? In a mining pool?
Yes, it happens inside the mining software. Each time you're mining for something, the first thing you do is you create a new block, stick all the transactions in, and then you try to find proof of work against that new block. And you do that every time you're trying to find a block. So that decision happens in building that new block to find the proof of work, and it's part of the mining software.
Thanks for clearing that up.
So miners are really already setting the price. They're setting the price by making a choice. And that choice effectively is the decision of what transactions to include in the block based on the fees that are in those transactions. Now, the question is, how does a client try to predict what's going to happen there? And this is a development has been done in this particular case. I think Gavin's been writing essentially code that uses information from previously mined blocks to try to decide what the level of fees in the network is right now, and to create transactions with the least fees you can pay and get away with the confirmation time you want. And to do that, what Gavin is doing is he's using a historical analysis of transactions in the several past blocks, then taking the median fee per kilobyte, median, not average. That means the point at which half the transactions are more expensive and half the transactions are less expensive. And the reason he picks the median is to avoid gaming by the miners, where they could stuff it, where a few miners could basically rig the game to increase the fees. And the goal is, if you have this simulation done effectively in the client, then it can decide what transaction fees to include with a relatively high degree of certainty that it will achieve its confirmation time goal with that level of fee. And it's relatively hard to game because it would take collusion by multiple miners or mining pools, and any mining pool that broke from that cartel would reap the benefits of competition by drawing all the transactions that have not been serviced. So it's relatively efficient market with good feedback loops, a good price discovery mechanism, and fewer opportunities to game. And it's a market rather than a fixed fee system. So that's the advancement that Gavin's suggesting, and I think it's a great next step towards having a market-based transaction fee.
You know, reading about this really made me think about how Bitcoin compares with the existing financial system. Because, I mean, you could look at what's happening here with how these fees are set in a really similar light to how we use LIBOR as a metric to set rates in the real world and many other markets that are out there, and how, because there are so many people participating in the mining system, there's really no advantage to trying to game the system. Whereas with a closed system like the LIBOR system, where everyone is participating in the regulated environment and you have to be chosen to be on this board, suddenly the opportunity for collusion to try and fleece the people who you're supposed to be providing a service to just goes through the roof, it seems like.
I have the concern that no system can be designed that will not be gamed given sufficient opportunity and market participants who have developed an advantage for themselves within the market. All market systems get gamed eventually. Now, the real advantage with Bitcoin is that even if Gavin sets this market discovery mechanism today and it starts getting gamed, he can change it in the next version of the client and then change it again and then change it again in a very public, consensus-driven approach that has very obvious results in the market. That's what you can't do with LIBOR, because you discovered the scandal 4 years ago, and what exactly has changed in the calculation of LIBOR? Nothing. Markets will be gamed. The question is, do you have the capability to flexibly adapt to that gaming, hit the reset button, and level the playing field again? All of the other systems are too rigid. Bitcoin is flexible enough to do that. That's the key.
So Mike Hearn wrote a excellent FAQ on the Bitcoin forum about the new payment protocol. And basically what this is it's going to change the way that you can send Bitcoin payments. And this is going to take a little bit of explaining. So I'm just going to read through his FAQ. Recently, Gavin merged support for something called BIP 70, 71, and 72 into Bitcoin QT. BIP 70, aka the payment protocol, is intended to be a big change to how people use Bitcoin. A lot of questions come up repeatedly, so here's an attempt to answer the most common ones. What is the payment protocol? Old timers, of which I am not one because I don't remember this, but old timers will remember that Bitcoin version 0.1, the first version ever released, allowed you to pay people in two ways. One was by entering a Bitcoin address. The other was to enter an IP address. If you entered an IP address, your computer would connect to the node on that IP and run a rudimentary payment protocol that involved asking the node for a fresh public key, then uploading the payment transaction directly. Satoshi thought that this payment protocol would be how people mostly use Bitcoin. It had some advantages, like guaranteeing a fresh address. He originally intended addresses to be used only for when the recipient was offline, but he was wrong. Addresses quickly came to dominate and hardly anyone used the pay to IP feature. Eventually it was removed. Did either of you guys ever use the IP feature?
Nope.
This must be really old school, because if Andreas doesn't remember it, you guys both don't remember it, and I don't.
This is 2009 and early 2010.
Yeah,
so it's way before most of us.
Yep, yeah, back in the day. So why did it fail? Why did this connecting to an IP address thing fail? One reason is that it wasn't very secure. Anyone who could man in the middle your internet connection, like someone who was sharing your Wi-Fi, could steal money sent this way. Another more practical reason is that back then, there were no online shops that accepted Bitcoin. In fact, Bitcoin was a Windows-only pure GUI, graphical user interface app, with no JSON RPC API, a lot of three-letter words, so nobody could even build online shops. So basically, yeah, nobody was accepting Bitcoin in their online stores at that time. So you never knew if the person you were trying to pay would be online or not at the time, meaning giving an address was more reliable. Also, NAT, firewalls, etc. What's NAT?
Network address translation, the fact that many IP addresses are proxied by a firewall or proxied by a router, so you don't have a public address.
The JSON RPC API, Andreas, that's what we were talking about earlier with how most applications interface with Bitcoin?
Yeah, that's the northbound interface of the Bitcoin D application. It's the interface that allows other applications to build on top of it and gives access to the Bitcoin network and system.
So Mike Hearn says but it wasn't a bad idea. So now we're bringing it back, but with a better design. The hope is that over time, this will come to replace Bitcoin addresses for most usages. But don't worry, addresses aren't going to disappear. They'll still be around if you want them. So, okay, that sounds good. I had a little panic when they said this is going to replace Bitcoin addresses. What? But they'll still be around.
I really like that this, this has seemed like it's a theme in 0.9 is that they're adding options, but they're not taking away any options. Is that the way that this is going to progress, where we'll just have things added and, there will be more options over time? Or eventually will some options like addresses, could those be eliminated and removed?
A lot of the code development involves eliminating things just as much as it involves adding things. I think it's an important balance to maintain. You leave too much CRUD from the past in there, then you have to implement it backwards compatibly with everything you ever did in the past. That makes development complex. I think the development team has done a fabulous job of dropping obsolete features when they're obsolete and adding features when they're needed and offering choices where necessary and not offering choices when there shouldn't be choices. It's a very delicate balance, and I think Gavin's done a great job on it so far.
Yeah, it seems like this is a theme. There are more options in this new thing, and that could only be good.
Well, in some cases it's good. In other cases, it is the development group job at some point to make some decisions and then make those decisions happen. Some things are not just about having a choice. Because if you have a choice on everything, then you really have no direction or strategic vision as to where you're going. It's just everything is optional. So right, I think it's about maintaining, a balance between making decisions and giving choice.
Yeah, I mean, with a feature like how you send payments, and basically that affects how everyday users use Bitcoin. So it seems like that might be a thing that's really important to have options for.
Yeah, absolutely.
So how does it work? It's a way to format a small piece of data, think file, that contains instructions on how to pay someone, a payment request message. Then a formal specification of how to satisfy those instructions by submitting a payment message. The data is designed to be extensible in the future so we can add lots of useful features. In the future, clickable Bitcoin links will look like this. And then he pastes a link that basically says Bitcoin, and then it has a Bitcoin address, and then a question mark, request equals, and then a URL like bitcoinstore.com/product. When clicked, your wallet app will download the request URL and read the payment request it gets. The request message contains another URL, which is where to submit the finished transaction to, instead of or as well as broadcasting it to the P2P network. I need some help understanding that, Andreas. Basically, you're going to click a link, and what happens after that?
I think the way to understand the payment protocol is to think of it compared to the current situation. When you try to buy something from a store, they give you an address. You put that address in your client, and then you create a transaction that goes out on the network and eventually reaches back to the vendor. That's a very loosely coupled transaction. All they gave you is an address, and then you just kind of throw money at it out there in the ether and hope that some of that sticks and the merchant sees that transaction come back to them. This is a much more tightly coupled sequence where it's a 3-part transaction. You ask them, how do I pay you? They send you the parameters of how the payment should be made, where the payment should be sent to. And then you send back to the vendor the transaction sign, the signed transaction itself. Now, that's a key point because for many vendors, if they have a way of verifying the transaction came back and went onto the network, they can even accept it with 0 confirmations. They can trust that it's properly signed. You're not likely to double spend right there, so they can give you a 0 confirmation. Whereas before, they kind of threw you the address and then listened onto the network and hoped that something came back to that address and that it was from you and it wasn't injected as a double spend and all of the other things. It's a much more tightly coupled interaction, which also allows you to deal with problems, right? Because you give an address and then you send a payment, but it's not the right payment. How do you do a refund? Do you need to send more money? Is the invoice filled? Did you get a receipt? All of those types of interactions at the moment are outside the scope of the payment. All you've done is sent an address. Whereas with a payment protocol, all of those could be in scope, could be properly defined. So you could have all of those separate parameters. It's going to make point of sale so much smoother.
That sounds like it's a lot more friendly to merchants who want to use Bitcoin or accept Bitcoin.
And for users too, because keep in mind, up to now, the way to make a payment is copy a 37-character string of gibberish or take a photo of a weird square with dots on it. Whereas the new system is basically telling your client to go to a website and then it does some things in the background and you just get an invoice or a receipt and a payment. So it's going to look much more like a payment system that you know. It's going to be much more user-friendly because you can hide the 37-digit gibberish. You can hide QR codes. You can make it simply about exchanging a URL, which you could do over Bluetooth, over near-field communications. You could do a number of, or with a QR code again if you want.
The first thing I wondered is there a potential for exploitation in this? Like, could somebody basically disguise a link as something that looks like a payment request URL and it's actually a malicious script that steals all your Bitcoins?
Yes. This introduces URLs into the payment system and introduces an HTTP GET. So the clients that do this will have to very carefully process that URL and very carefully process whatever comes from that URL because it's not a trusted system. Really, that's not much different from scanning a random QR code and, hey, let's see what happens. But it's much more explicit. So I think clients that implement this will obviously take the necessary precautions to ensure that any data they receive is not compromised and is not dangerous.
Satoshi Dice, the most notorious Bitcoin gaming site, has unveiled its newest creation, Tribute. In Satoshi Dice Tribute, bets occur off the blockchain for fast and exciting gameplay. Deposit Bitcoins and start playing with zero confirmations. All bets are provably fair and easily verifiable. Tribute is also social. Players compete with each other, and the top 3 players at any given time receive a portion of the bets from every other player. The rankings reset at midnight, enabling anyone to become the leader with a few lucky rolls. 1% of all Satoshi Dice earnings will be donated to Sean's Outpost. To kick off the new game, the first 1,000 players who lose 0.1 Bitcoin will have that amount automatically returned to them risk-free. U.S. players are not allowed because America is a free country. The ghost of Satoshi is waiting for you. Find her at satoshedice.com/tribute.